Hello guys. So after we already learned some basic methods about the time series regression model, we learn about the other ways to do for the seasonalities and also for the component decomposition of the time series. We now turn into the new topic about the exponential smoothing. So in these chapters, we go into you for some kinds of method about how the people can use their average, the weighted average between some kinds of historical information, but however, it's not like equally distributed between the historical information. But the people want to relies more on the more recent data, why the kind of like older data they should get the lower weighted, and that should be the way the people run for the fraction of their exponential smoothing. And with this, we go into practices. So first of all, I'm going to use one more time for the FPP2, okay, the FPP2 packet. And to do this, I first of all wanted to use the data oil. So this is the annual oil production of the Saudi Arabia. Then remember, this is the annual oil production in the million of ton from the 1965 to 2013, a time series. So I want to explore the data first. How we gonna do it? So I want to see for the structures of the oil, okay, and it includes like 49 observations from the 1965 to 2013, and if possible I want to just auto plot it. I want to see the time series first, okay. The data look like they have a kind like a tendency maybe like they increase compared to the beginning of the period. That's around like 120 or 110. Now in the end of the period, it's jump up to more than 550 or something. So it looks like you have a trend, but it's not so obviously. And we also cannot figure out any kinds like seasonality pattern. So this is the time for us to just not use for the time series decomposition part, but we have to go into another way to just deal with the time series exponential smoothing. Okay, so now let's do it with the oil data. Okay, so because some of the data are not so stable, I believe like I would just want to use for the data from the late of the 1996 into the 2013, and that will be enough for me. So that's the reason why I want to create for the new oil data. That's a new object, right? That's select from the window. Okay. Oh, remember, I sometimes want to use for the library of the tidyverse. Okay. Tidyverse. I want to use for the pilot operation. Okay, now I want to use for the window of the oil, and it should start from the 1996. Okay, that's my data. It should be the time for me to plot the time series of oil data. Alright, so oil data now I will apply for the oil data. Okay, and I apply for the auto plot function, of course, but however I want to add into the y level. This will be oil in the million of ton. Okay, and then maybe I will just close like this, and I add in for the x level 2 of the year. Okay, so it what it look like. Okay, And if I really want to add into the CG title like onway, I can add in like the oil production of Saudi Arabia. Okay, and this is how it look like. Okay, now let's go and use for the simple exponential smoothing model. Let's first of all apply the naive method and average method for forecasting. Okay, so with the R data, okay, I'm going to apply for the naive method first with about like 5 periods ahead. Okay, and you remember about that if you really want to see and remember in the end of the tails of the R data. Okay, you can see like this will be all the data that's coming to the end. Now, so they use for the final last observation to use for the kind of assumption that does continue in the futures, and that should be the how the naive methods work. Okay. Another way I apply the average method. So that's a mean forecasting x equal to 5. Okay, one more time. And this you take for the average of all the historical data, and then we assume that will continue in the future, and that's how the two of them will be worked on. Okay, now let's compare it. Okay, let's can compare it like we can use this for the sorry the oil data, the symbol exponential forecasting. Okay, exponential smoothing forecasting. Okay, and I wanted you for the now the oil data one more time, but I apply for another symbol exponential smoothing. This is the function, and then I apply for the x equal to 5. Okay, so I got it, and this will be how it's we going to deal with that one. Okay, that could be something like the combination between the naive and the mean methods, but with the kind of like the cadence, the weighted. Alright, and this is how all my data will be worked on. So I save it here. This will be forecasting. Maybe this will be for the naive. Okay, the first one, the FCs of the mean. Second one, and last one, FCs that's saved for the symbol exponential. Okay, and we in some way like if with the function like this, I can do it with the symbol. Okay, with the the summary for the function of the FCSCS, and you can easily see how they can represent for the result of the model. So with the exponential smoothing, they will automatically generate for the alpha. That could be the order. Okay, so this will be over here 0.8339, and initial L that should be 446. Sigma that should be standard deviation of the residual, but we will talk about that later. And also they provide for some kinds of criteria about the quality of the residual, how would be the criteria for the model selection, and also for the errors. Okay, that will be very good. Right, and you sometimes you can like retrieve the data of accuracy. Okay, of the accuracy. So if you want to do it, you one more time can use for the accuracy function, and you use this for the abscess of the SES here. Okay, so they would retrieve all the information about the accuracy criteria, including for the MEs, like the mean of errors, the root means of square of errors, MAEs, MPE, MAPE, MASE, and ACF. That should be all the thing you can run it on. Okay. Alright, and also you can plot. Okay, you can use for the auto plot of the FC SSE. Okay, if you just run it automatically, they could be look like this one. Okay, you can compare them. Okay, but I will put them into the series over here, right? Name it could be the S. Okay, I would say symbol exponential smoothing. Okay, and then with another one, I add for layer auto layer of the FC, but however, does will be run on the sorry the SE of the nave. Okay, alright. However, series here this would be the symbol. What would that would be the nave method. Okay, another layer. Okay, so abscess of the not the name but the mean method. Okay, and the series name I will put it on like the average method. Okay, you can compare all three of them over here, and you can see how the result it would be. Okay, and also I will add into another layer. But however, because it's all the methods look like over here, they have a kind of the section, right? The SE, so the standard error. So I will put them into form to make everything clearer. Okay, and also here SE equal to 4. Okay, so this will be how it could look like. There's something wrong? I don't think so, but I don't know why. It should be something like the name methods have been already declared and it has been like overlap on each other. So I will try to just fit for my method in not the thing like this, but for the fitted result. Okay, the fitted result of the FC slash. Okay, and I would say like this the fitted. Can it look like? Yeah, it could be like this one. Okay, and let's click on and do for the clap. Okay, which year and the Y level with the oil in million of ton. Okay, that's it.